Hello, everybody. My name is Duane Hamacher. I am an associate professor of cultural astronomy in the School of Physics at the University of Melbourne. I am an American-born academic and astronomer with a PhD in the social sciences, and I've been working in the world of Indigenous astronomy for about 13 years. And a big part of what I do focuses on education and science education, how we can amalgamate and bring together the two different worlds of Indigenous knowledges and Western science together for educational curricula and programs. I'd like to begin by acknowledging that I am on Bunurong land in the inner west of Melbourne. It's the traditional lands of the Bunurong people of the Kulin Nation, and I would like to pay respects to the elders past and present. So what I'd like to talk to you about today is how we can work on integrating the crossroads of Western science and Indigenous knowledges. And we're going to look at a few different ways that we can do that. And I'm going to give you some examples of how we can accomplish this. So it's really important to understand what we're trying to get across. And one of the things that we're trying to get across to students is that there are a lot of different ways of doing science. There are a lot of different ways of conceptualizing what we think of as science. If you ask most scientists to give a definition of science, you get a pretty textbook standard definition. But if you'd ask an historian or a philosopher of science, you're going to get probably some very strange looks, usually laughing reactions, because it's far more complex than what we typically teach students in high school. The way a field biologist, a theoretical astrophysicist, a mathematician, a psychologist, an archaeologist, any of those areas, the way they're all going to do science are going to be quite different. There are going to be some crossovers, but overall, it's going to be very different ways of doing that. But at the very foundation, it is about trying to understand the world around us. We do that through observation, through experimentation, through deductive knowledge, deductive reasoning, trial by error, experimentation. We build this body of changing and dynamic knowledge that brings in new evidence that tries to explain ideas and hypotheses that we have about the world around us. And despite what many people might think, this is not something that is restricted to Western science. It is something that indigenous cultures have developed for a very, very long time. In fact, long before Western science was ever around, there were indigenous cultures around the world trying to understand how everything around them worked. And what you find in indigenous systems of knowledge is that they're very holistic and they're very interconnected. This means that you don't look at a system in isolation, you look at all the systems together and how they're directly related to each other. Now, as a non-indigenous person, I'm probably not the best person to be going into too much detail about that. But what I am doing in this space is recognizing and looking at the scientific layers of knowledge within these oral traditions, within these systems of knowledge, and understanding how that information and that knowledge is passed down to successive generations. And that, of course, is done primarily through the idea of orality or oral tradition. Western science is very much rooted in the written word. We publish our research in papers and books, but it's oral tradition in indigenous cultures that are the primary modes of transmitting information. So you've got to have this very significant, very large body of knowledge that ties everything around you together. You've got to pass that on to successive generations while maintaining vitality. And how do you do that? Well, you pass it on through narrative and story. You pass it on through song and dance. You pass it on through what we think of as artworks, through craft, through material culture. All of these are ways of transmitting knowledge. Now, the narratives oftentimes get dismissed by scientists as, well, they're myth and legend, they're just fairy tales, they're stories. The reality is that these narratives and these stories are a way of being able to embed information, be able to embed systems of knowledge into memory. It's a great mnemonic to be able to utilize these narratives. And these narratives often use anchor points in the world around us. It's something that is called the method of loci. And it's how we by being humans, have associated and evolved over time to associate memory to place. And place can be an object, it can be a thing, it can be the landscape, it can even be the stars above. So by looking at how information is encoded into oral tradition and how that's generated as a mnemonic system and then passed down, we can see how these systems of knowledge interrelate to everything around them, because the narratives and the songs and the dances show how everything is interconnected. And then we can see how long that information is being passed down. And there's very strong evidence that oral traditions can be passed down while maintaining vitality for thousands, potentially over 10,000 years. Now, if you want to learn more about this, there are two books, both written by a colleague of mine named Lynn Kelly, who wrote The Memory Code and Memory Craft. They're both fantastic at explaining the techniques behind memory, how those apply to different systems of knowledge, and also how they can apply to the material world around us. In particular, it's of interest to archaeologists, but really it's of interest to everybody. Memory Code goes and really talks about how a lot of ancient archaeological sites are actually developed as memory spaces. And Memory Craft goes into the indigenous techniques of how you actually memorize things. Now, one thing that the elders talk about quite often, in fact, every single elder that I've ever worked with, whether it's here in Australia or around the world, they all say the same thing. Everything on the land is reflected in the sky. The sky is a map, it's a science book, it's a textbook, it's a law book. Everything you want to learn about the world around you is reflected and anchored in the sky. A colleague of mine, Professor Annette Lee, who's a Lakota astrophysicist and artist, who is now at Arizona State University, developed a lot of educational curricula around this exact area. And she refers to it as Kapemni. And Kapemni can be thought of as sort of like two teepees standing on top of each other. They're a reflection. Everything above is below. So the work of Annette Lee is phenomenal in this space of integrating indigenous knowledge into astronomy education in particular. That's what she did her entire doctoral thesis on. And you can learn more about that at nativeskywatchers.com. So if we're going to be looking at things, for example, here in Australia, I want to use a couple of different anchor points for this. And I find the idea of using anchor points to be very useful. So for example, we can look here at the Milky Way, something we have a very beautiful view of in the Southern Hemisphere, not so great view of in the Northern Hemisphere. But what we're looking at right here is the center of the galaxy. We can see the stars of Scorpius and Sagittarius right there in the galactic bulge. And petering off to the side, you can see the pointer stars in the Southern Cross, which are extremely famous down here in Australia. Well, just this part of the sky can be used as an anchor point to teach astronomy, astrophysics, indigenous astronomy, biology, weather and climate, a whole load of different things. I'm going to explain how we can actually do that. So one of the very common motifs, the very common constellations that we see in the sky from Australia is not one connected by the bright stars, but one connected by the dark spaces between the stars. And the most famous example is that of the celestial emu. It goes by many names, Gawrgay, Chingal, Gurgaman, depending on which of the several hundred different Aboriginal cultures across Australia you're looking at the emu in. So there are 300 plus different languages in Australia. Each one is quite unique, and each one has its own stories about the emu, its own names for the emu, and its own narrative about how the emu got into the sky. But at the foundational level, they all tell you the same thing about what the emu actually means. So the emu is traced out by the dark spaces in the Milky Way. The Coalsack Nebula is the head, right next to Crux, the Southern Cross. And the dark spaces that go down into the galactic bulge, into Sagittarius and Scorpius, trace out the body and legs of the emu. So what I want to do now is share a little bit of knowledge with you that was shared by Uncle Gillar Michael Anderson. Uncle Gillar is a senior UAU lawman and leader of the UAU Nation. And he published some research with colleagues of mine, Dr. Bob Fuller and some others, about his traditional knowledge of the emu in the sky from UAU country. This is northern New South Wales, near the border of Queensland. So he talks about how in UAU culture, the position of the emu in the sky throughout the year, just after sunset, tells you different things about the seasons, about the behavior of the emu, and about what things people need to be doing. He talks about how in April and May, you're going to see the emu running. At this time of the year, it's a female running, and she's running because she's chasing a mate. She's chasing a mate because with the emus, it's the males who sit on the eggs and the females who chase the males around to mate. I'm going to explain a little bit more about that in a few minutes. A little bit later, a couple months later, sort of June, July, during the full winter here in Australia, or what we think of as winter in the Western terms, you've got the emu in the sky across the sky, kind of lying flat across the sky. And at this time of the year, it's no longer an emu running, it's now the male sitting on the nest, incubating the eggs. A little bit later, come August and September, the Milky Way swivels around to where it's perpendicular to the horizon, sort of diving straight into the horizon towards the southwest. And during this time of the year, you see the male emu getting up off of the nest because the eggs are now hatching. It's the male's responsibility to rear the young. And as you go into later into spring, into October and November, you see the Milky Way still swinging around clockwise in the south. And even though it sort of appears like the head and back of the emu are laying flat across the horizon, the elder says that, well, actually now it looks like the bum of the emu, the rump of the emu, sitting in a water hole on the horizon. The emus sit in water holes at this time of the year, and they sort of act like a celestial Archimedes. The weather heats up, the rainfall increases, the emus sit in the water holes to cool off. And as they sit in the water holes, it displaces the water, which falls as the seasonal rain that comes down in October and November. And then come the months we think of as summer, December, January, and February. The emu is pretty low on the horizon. It's essentially set below the horizon. It doesn't come out again until about March. But really, it's April when it's fully above the horizon after sunset. Well, that's interesting. And we can also see that it links to ceremony, because the time of the year in panel C in August and September, there are these ceremonial sites that are mirrors of the Milky Way that are actually aligned towards the Milky Way itself. In UAU culture, they're called Bora ceremonies, and these are for initiates. This is where the men bring the boys into manhood during a special ceremony. So you can see that reflection of the ceremonial ground in the sky, which consists of two circles, a larger and a small, connected by a pathway. And they're directly linked, directly mirrored from the emu in the sky, and they align towards the southwest at that time of the year. So when we look at the emu in the sky, we can think of different ways that we can anchor how we teach students about science. We can look at basic astronomy. How do you name stars? What about the different nebula and the constellations that you're going to see within the emu? Sometimes the planets are going to pass by, as will the moon, because this part of the sky is near the ecliptic. And you can be able to discuss things with students about the observational properties of astronomy. You can talk about even proper motion and precession and star positions, all these different characteristics, which are anchored in the emu. And some of them are actually tied in with the emu itself and some of the narratives and the stories. So for example, one of the official IAU names of the fifth star of the Southern Cross of Epsilon Crucis is now Guinan. And that was something that we helped make happen within our working group on star names in the IAU. So you can actually tell students that the Waterman Aboriginal name for a dilly bag filled with songs of knowledge is the formal name of Epsilon Crucis. But there are also other narratives. In Wergaya country in northwestern Victoria, they talk about Chingal, which is a giant sort of human-eating emu. And the story goes that there was this emu who was killing people, and these two hunters were sent to kill the emu, Chingal. And Chingal actually chased one of the hunters up to the top of a tree. And the ancestors in the sky were so upset about his cowardice that they turned him into a possum. So Bunya is the name of that possum, and it's the top of the celestial tree, which is the Southern Cross. You can find that in a lot of cultures in Southeast Australia, the Southern Cross is seen as a tree. In some parts of the country, it's seen as a footprint or a stingray or a lot of different things. But down here, that one anchor point ties in with that particular star, name of Bunya, and being chased to the top of the tree by Chingal. So we can look at it in astrophysics terms. We can look at those dark spaces in the sky that make up the dark constellation, those dark nebula being areas of cool gas and dust. You can talk about star formation. You can talk about the shape of the Milky Way, why it's a large flat disk through angular momentum. You can talk about those physical principles in the actual appearance of the emu. You can even talk about the spectral types, because even though we're looking at the emu with respect to the dark spaces, obviously we're going to see all those bright stars around. And some of the properties of the stars are going to be different from each other. Another thing the elders constantly talk about is how a person's ability to be a great astronomer is tied in with their ability to read the stars. And reading the stars means being able to observe, understand, and interpret the changing positions and properties of the stars. So we've seen with the emu how it rotates in the sky throughout the year, links to the behavior of the emu itself. But it's also about the changing properties of the stars. You know, looking at their colors, their brightness, do any of those things change? So we can look at spectral classifications because you talk about star color. You can talk about how in Western science we have the Hertzsprung-Russell diagram and stellar classifications, but also some traditional cultures have their own stellar classifications. The Luritja people in the central desert of Australia have their own classification system, which is very similar to this. They break stars up between those that are basically white and those that are red. They're Joker if they're white, they're Tataka if they're red. There are those that are a bit of a crossover between the two. Those are sort of yellowy, orangey kind of colors. That's just a combination of those two words, Tataka Jokera. And then those that are extremely red, the Tataka Endora, which would be stars like Betelgeuse, Antares, and Aldebaran. We can look at biology. We can see how astronomy links to biology. And in this regard, we can see how the emu in the sky, its position changing throughout the year, tells you about the biology of the emu itself. It tells you about its behavior patterns. It tells you about food economics, the eggs. The eggs are the main source of food that link to this particular animal. So at the early part of the year, when the females are running, they're chasing the males to mate. Well, first off, you can ask, why are the females running? Well, the females spend a lot of time feeding. They chase around the males to mate. They lay the clutches of eggs, which can range from 5 to 10 to 15 eggs, and they can lay several clutches in a year. It's the male's responsibility to sit on those eggs. And when the male sits on those eggs to incubate them, he doesn't move at all except to protect it from any potential predators. But he does get up and turn the eggs over a dozen times a day. So why is the male doing that? Well, the emu eggs are very large. They can contain anywhere from 6 to 12 chicken eggs. So you can imagine a clutch of 25 or 30 kilograms of eggs over a breeding season takes a tremendous amount of energy for the female to produce. She's not going to have the internal energy mechanism to produce all those eggs and then sit and incubate them. Because during that entire time, the males don't eat, they don't drink, they don't do anything except sit on those eggs. So they have to build their reserves. So that's why the roles are the way they are with the emus. Now, when the emu's seen rising at sunset or after sunset, that's when people would go and collect the emu eggs as a food source. It's a very nutritious food source. You can look at the actual nutrition value of the emu eggs themselves. You see the incubation period of the eggs is about 59 to 60 days, roughly 2 months. And when the Milky Way starts swinging around, you can see that the emu getting up off the nest is when they begin brooding the young. You can look at how long it takes to fledge the youngling. So you can see how all these things link together. And of course, it also links into seasons and climate. We've seen the different seasons. You know, you compare the 4 Western European seasons. The emu cycle really starts in the autumn. Incubation occurs over the winter time, spring times when the young are being born. And you can see how rainfall ties in with this, because we looked earlier about when the emus were seen sort of sitting in the water holes later in the year. Well, when you look at the rainfall up at that part of the country in northern New South Wales, there's a huge peak in rainfall that occurs in October and November. So it ties in with the temperatures, it ties in with rainfall, and it ties in with seasonal patterns. I do want to point everybody towards our website, which is aboriginalastronomy.com.au. Thank you.